All right, so here's a little explanation for this. No, it is not magic. Uh, I'll just let you know that simply all I'm doing back here is I'm squeezing the bottle. And when I squeeze the bottle, it goes down. And when I release, it goes up. But why does that even do anything? So if we think about it, here's what I do. Let's just look at this test tube. The test tube, the top half of it approximately is full of air, and the bottom half is water. Now, what we know about water is it takes up pretty much the same space it's going to take up. You don't change the volume of it very much. Whereas gas, we know that we can compress it and not. So as I squeeze, look at the level of the water where it goes. Okay, as I squeeze, it moves up, right? Squeeze, release. And if I really squeeze, it really goes up. So what's that doing to the test tube? Okay, so the test tube is filling with more water. Is it losing air? Is there anywhere that air can go? Do you see bubbles coming out of the test tube as I squeeze harder and harder? No, there's no bubbles coming out. So that tells me that the same amount of air is in the test tube as before. The tape is wearing out and it's getting stuck on the top. So that air is still the same amount of air, but the water, there's some water from in the bottle that because of the pressure is being forced into there, which means that there is more water in this test tube. And at a certain point, when that amount of water makes it so that the overall density of this test tube, the overall density, you take all of the mass of that test tube and its contents, as soon as it is a greater density than the water, it's going to sink in the water. So that's what's happening here. We're making the overall density of the test tube greater and it'll sink. Now, if I really squeeze, it's going to go faster. Okay. If I barely squeeze and barely make it greater, it'll go down, but not nearly as fast. Okay. At a certain point, I could actually make it so that it has an equal amount or equal density as water. And right here, the overall density of this test tube and its contents, including the tape, is equal to water. And this is what's called being suspended. So it gets suspended in here. This is sinking or lowering in depth. This is raising the depth or moving up. Okay. Suspension is when it stays. Now there's something called buoyancy or buoyant force. It's the same thing. And essentially what it is this force that's acting up on you. So in a previous experiment, we used a spring scale and we learned that water has a buoyant force and it forces objects up. Now, if that force is not as great as the gravitational force, the force down, the gravity down, then if it's not as much as the gravity down, the thing will sink. Okay? But if the force is greater than the gravitational force, it will move up. And if it is equal, so the buoyant force and the gravitational force are equal, then they will stay the same. And we'll have a little a picture in the Google form on this. Again, this all has to do with pressure. When I squeeze the bottle, what I'm doing is actually making the volume of the bottle less. And by lowering the volume, I'm increasing the pressure. And those particles, they need to go where there is less pressure and push things in. And where they do is they go into that test tube and they compress that air in there. So this kind of illustrates all the things we're learning in this unit. Density, buoyancy, pressure. It's all in one little activity. It's not working because the glue is stuck. I hope that explains it.